Yes, our data specification is the result of 34 telephone conferences, 5 physical meetings, 2 cross-team meetings, 3 Inspire conferences, and 1 joint meeting from 4 of us with a working group, a floods drafting group, who is a responsible group on EU level to prepare the reporting requirements for the implementation of the Floods Directive. Because the Floods Directive is the only existing directive that addresses one hazard in our theme. This is our theme, our working group with specific expertises for the different domains. With the exception of storms, we covered nearly every hazard. Our group was supported by different organizations. I don't want to stress this issue too much. We considered as far as possible those 32 reference documents which were provided as the outcome of the user requirement survey. The work carried out by several projects on EU level like Plan for All, Orchestra, SafeLand and others, and also the requirements from the Floods Directive, inclusive the SIS documents like reporting sheets, XML schemas, and the WISE GIS guidance. Also, we tried to consider things set by the working group Hydrography from Annex 1, like feature class inundated land as candidate type, and they also expected us to specify embankment. We included inundated land in our data model, but embankment, we felt that we are not responsible for this and gave it back to Annex 1 hydrography. And we tried to consider all those nearly 400 comments from consultation. To put the frame or the scope for our theme, we analyzed all those input documents from user requirement survey and other sources, and we got additional information while the production of the use cases for floods as cross-thematic hazard, landslide, forest fire, and earthquakes. The starting point for our work was, of course, a definition, what is given in the legal text. And here I highlighted the words in the definition which are considered in our risk function. Risk is the function of hazard, vulnerability, and exposure with regards to social, environmental, cultural and economic assets in the zone, respectively area of interest. So we carried out 4 kinds of spatial object types that are derivated both in vectors and in coverages. One is observed event, because observed event in the terminology of Floods directives, these are past events, are very important information to get knowledge about areas prone to different hazards. The second spatial object type are those hazard areas. Then the third is risk zone and exposed elements, because for us it's very important to distinguish between hazard areas and risk zones, because we want to to distinguish between a normal event or a normal natural phenomenon and disasters or things which causes damages. So for each of them, the following feature types have been created. An abstract feature type that contains the properties known as attributes or constraints of the spatial object that are common both in vector representation and to its coverage representation. From those abstract feature types, we generated a vector feature type and a coverage feature type, and with specific properties to vector or coverage representation, because we get known of the fact that a lot of data providers have either vector data or coverage data, and we should enable them to provide those data as the best they can. Therefore, it's not necessary to provide data both in vector or in coverage, but either in vector or in coverages. So we try to combine this in a merged NZ core model, like shown in this figure. And so we have also 4 core implementing rules, which are when a risk zone feature is associated with a hazard area, then the risk zone feature and the hazard area feature must overlay, at least partially. When a risk zone feature is associated with an exposed element, then the exposed element must overlay with the risk zone feature, and the same, or near the same for coverages. We have only 2 NZ key code lists that are very generic to facilitate semantic interoperability, and more detailed terms are extensible by the member states or data providers to follow the narrower concept. That means that data providers can add specific classifications of type of hazards or exposed elements on regional, local, or more detailed level, etc. So we have very generic code lists for natural hazards. There are only geological, hydrological hazards. For floods directive, here tsunami is integrated, and then we have meteorological and climatological hazards, which are in terms of floods directive all other types of floods. In addition, we have fires, biological and cosmic hazards, and the categories of exposed elements on first level are similar to the types of adverse consequences in terms of floods directive, and also those 4 categories we defined on first level: human health, economic assets, environmental assets, cultural assets. It's nearly the same in terms of floods directive. Why we have chosen the floods as an example for the extensibility of our core model is what I have said before, the existence of the floods directive, and the overall idea was to take the core model, specialize it to make it to meet the floods directive requirements, and to show how to use the navigability of the links to avoid redundancies and constraints to ensure the coherence of the model. Of course, we also have links to other thematic working groups, respectively themes. In terms of hazard modeling, these are the themes land use, hydrology, geology, and elevation. For exposed element modeling, the utility and public services, buildings, administrative and legislative boundaries, statistical units, and population distribution, and also for input data like water flow in terms of floods, environmental monitoring facilities, and in terms of consequences, it has effects, maybe effects on area management and land use. The next stages will be to address some final member states' concerns, the publication of the implementing rules to promote them widely, and still a lack of understanding beyond the legal mandated organization and ethics, and the formalization of the maintenance process. And I would like to finish with this nice figure provided by our colleague from Madrid, which shows the relationships between hazard, exposure, vulnerability, and risk. And thank you for your attention.